We're here at Geneva at the moment, and the current theme of the show is very much new architecture in terms of car manufacture, new methods, lighter cars, and obviously being English, we're very interested in Lotus cars, and we're here with Phil Barker from Lotus Engineering, who is going to give us the lowdown on what we see here, basically. So, Phil, here you go. The stage is all yours. Tell us about, obviously, the modern engineering that's coming from Lotus at the moment.
Okay, we've been heavily involved in hybrid and electric vehicles for a number of years now, and this is really the latest application of some of the new technologies. And what you see here is a cutaway demonstrator of our Lotus Evora platform. We're already at a very good starting point because our vehicles are lightweight to start with. So when we're creating a hybrid or electric version of our vehicles, then we've already got a very good starting point. Essentially, the technology that you see here is we have a twin electric drive setup. So we've got two electric motors independently driving each wheel. Each electric motor is 150 kilowatts. So we've got a total of 300 kilowatts available to us as a peak power.
So this is a totally electric car. This is not a hybrid. This is total electric power.
We've added our latest range extender engine. So this vehicle is a series hybrid vehicle.
So a hybrid engine with independent drive from the two motors to each wheel.
That's correct. Yes. The hybrid drivetrain itself, there's no mechanical link between this combustion engine and the road wheels. The engine purely drives an electric generator. So we're getting 50 kilowatts of electric power output from the range extender engine.
So this is, in essence, a generator for the electric motors?
Correct. We've come up with a fairly sophisticated energy and power management system. So the 50 kilowatts that's coming from the generator can either go directly to the motors to drive the wheels, or it can go to charge the battery, or it can do a combination of the two.
And presumably there's a very clever ECU that works out whether it needs to charge the battery or whether there's high load and it needs to put all the power to the wheels.
Yes, that's right. Everything's dependent on the driver interaction with the vehicle. If he's wanting full performance, then we use the battery pack itself to drive the motors. If he's just steady-state cruising on a highway, for example, then we can use the range extender and bypass the battery completely.
Okay, so, and there's full feedback from the dash, touchscreen interaction.
Yes.
I'm also seeing voice selection. Is that future technology, or is this actually integrated?
This is integrated sound synthesis technology. With there being no mechanical gear train in this vehicle, what we've created for better driver involvement is a virtual 7-speed gear shift. So when the driver's driving, he pulls the gear lever, and we will momentarily back the torque off and reapply it so that it feels as though he's got a gear change.
So a virtual throttle blip, in essence.
Exactly, yes. So we have a virtual 7-speed gearbox. More importantly, however, is when he's decelerating and he's changing down through the gears, we can increase incrementally the levels of regen braking, so we're actually putting more energy back into the battery.
So like the KERS system that we saw in Formula One and in other versions of racing, in essence, or your own derivation? Similar
to some of the KERS systems that have been developed, but I think this is possibly the first example of a virtual gear shift. So we're controlling the level of regen braking through this virtual gear shift. So that's using the voice of the V12.
Okay, and it's a selectable synthesis, in essence, that you can have a V6 or a V12.
Slightly different engine note to the V6.
Yeah, slightly more shrill. And weight-wise, because obviously weight is the big talking point at this show, what are we looking at over a traditional model of this size?
A model of this size will typically increase by about 150 or 200 kilos, so it does take a weight penalty. What we're looking at is more modern battery technology that has got a better specific power output, for example, so you can retain the power and have a smaller, lighter battery pack. And those technologies are in development right now.
And where are the batteries housed on this model?
On this model, the batteries take place of the rear seats because the conventional vehicle is offered as a 2+2. So unfortunately, we've had to sacrifice the rear +2 seats for the battery pack.
So it's not a flat lithium or anything like on some other cars, so obviously that's another step to come.
Yes, if you're developing an EV or a hybrid vehicle from scratch, then you can fully integrate a battery pack, and it makes sense to put it as a flat pack underneath the floor. Your centre of gravity is lower, better vehicle dynamic behaviour. So if you're developing a vehicle from the very start as an EV or hybrid, it's possible to do that. It's difficult where you're taking an existing structure and having to integrate a battery pack.
For sure. But again, that's what Lotus engineering is all about. We've seen, from the very beginning, Lotus as an engineering company as well as a sports car company. So it's good to see that coming through in what we're seeing in this millennium.
Yes, I think it's fantastic.
Excellent. All right. Well, thank you very much, Phil, for your time.
No
it's
problem
been
at all.
good talking to you, and I believe we're off to see your CEO very shortly.
Very good.
Thank you.
You're welcome.